This is Mech 17 Cooling System Theory. You've already watched the video for how a cooling system works, and now we're just going to review some of the components of a cooling system. The first one we're going to talk about is antifreeze. Antifreeze is the liquid that runs around the cylinders and through the radiator and helps cool the engine. The thermostat, water pump, radiator pressure cap, sometimes that's just called a rad cap. Expansion tank, another name for that is overflow tank. Radiator hoses, those are the big ones. Bypass hoses, the water jackets, the cooling fans, temperature indicators, that's the gauge on the inside, and a block heater, especially here in Saskatchewan. So if we look around at our diagram, you should have this diagram to fill in, so you can pause the video right now and fill that in. Excellent. Engine coolant, let's talk about that first. It's a mixture of antifreeze and water. It's never straight antifreeze. The ideal mixture in moderate climates, and we're not a moderate climate here, but in moderate climates is about 50% antifreeze and 50% water. There will actually be a chart on the jug of antifreeze for you to look at and make a decision that way. Here in Saskatchewan, very often they call for a 60-40, 60% antifreeze, 40% water. We're going to learn how to test the strength of the antifreeze. That will tell us when it freezes, and that'll give us an indicator of if we need to add more antifreeze or not. Two types of antifreeze, basically. We have ethylene glycol antifreeze, and we have propylene glycol. Ethylene glycol has been around forever. It's based on ethyl alcohol, and so it's very, very poisonous, and it's very, very sweet, so we need to be careful with it to make sure that we don't drink it, or it's very poisonous. A tiny little bit will kill you. So and the reason why I know it's sweet is because sometimes it'll come up as steam where there's a leak or something. You can just taste it in the air, and it's absolutely gross sweet. Then the other one is propylene glycol. A lot of manufacturers are using that lately. It's less sweet tasting, it's less poisonous, and so that is better for everybody. So the next component we're going to look at is the thermostat. The thermostat controls the operating temperature of the engine, and that's the definition. That's what it does. So if you write down what does the thermostat do, that's exactly what it does. The thermostat controls the operating temperature of the engine. It makes sure that it doesn't overheat and doesn't stay too cool. Keeps it at the perfect operating temperature. And here's a picture of a thermostat. It's a little hard to decipher, but when we do thermostat testing later on, you'll see that this center part right in here on this bottom picture can move up and down. Here it's sealed. You can see how that center green part is sealed up against the case. Here it's moved down, and it's through this gap that antifreeze will flow right through there. So when the engine warms up, the thermostat will open, and that allows the coolant to flow through to the radiator. The purpose of a water pump is next, and it just moves the coolant through the cooling system. It's very important that it doesn't stay stationary. We need the coolant flowing past the cylinders through the radiator in order to do its work. Very often the water pump is driven by a belt, and that's driven by this one's called a fan belt, but it's usually driven by the harmonic balancer on the engine. So whenever the crankshaft is turning and the engine is running, that means coolant is being pumped in either through the lower rad hose or the bypass hose into the pump and then pushed out back to the engine. Purpose of the radiator: to transfer heat from the coolant to the radiator tubes to the air passing through it. So you can see our radiator here. This is called a cross-flow radiator because the coolant flows across. Thermostat sits right here. As the water pump, which is down in this area, is pushing coolant, it pushes it through into the engine, and then it goes through the water jackets, comes back up through the upper rad hose, down, across. inside the radiator there's a whole bunch of fins, and those fins, these are the tubes running across, and then the fins sit this way. And then as the air rushes past, either from the vehicle driving or because there's a fan right here sucking it through, the heat from the coolant is transferred to the tubes, and from the tubes to the air going past. So if you would feel the air over here, it would be cool. And as the air goes past, if you put your hand over here somewhere, making sure you're not sticking it into the fan, if you put your hand over here somewhere and you feel it here, it is hot, because it's taking the heat away from the coolant, away from the tubes, and transferring it out into the air. The radiator pressure cap is often misunderstood, and so we'll just make sure we understand it. The radiator pressure cap raises the coolant's boiling point. How does it do that? It does that by raising the pressure inside, because we know that the pressure inside of the radiator, which is down here, as it builds up, the boiling point goes up. And because the boiling point goes up, then we don't get boiling in the coolant, because that is counterproductive to cooling the engine. Water jackets. The water jackets are around the cylinders of the engine. So this would be a 1, 2, 3, 4, 5. This is an inline 6 engine, and you can see that the water jackets, they sit right in here, and it's just the coolant flowing around the water jackets, around the pistons, that allows the heat to be taken away from the cylinders and delivered back up through the thermostat into the radiator, cooling, and then the water pump sends it back to the water jackets. Cooling fans. The purpose of the cooling fan is to provide additional airflow through the radiator at low speed and when the engine is idling. So if you're driving around, air is naturally rushing through the radiator because you're moving, and the vehicle is moving. But when you're standing still, then the air needs to be sucked through. Otherwise, the air does not rush past the cooling fins, and therefore the air is not cooling the antifreeze. The last component is a block heater. Block heater is a lot like a old style coil stove element, and it just sits in water jackets, and this part sticks in there and gets hot, and this part here plugs into your house. And so when you plug it into your house, it creates heat right here, and that warms up the antifreeze inside the engine, and that keeps the engine not warm, but when it's in very cold conditions, then it keeps it from getting too cold, makes it easier to start, and it's easier on the engine in general. So what are we going to be checking in our shop? Pressure test is very important. The reason why we do a pressure test is because a vehicle will come in and it is leaking, and you can't find where it's leaking because it's sort of leaked all over the place. So what you would do is top up the antifreeze, and you would hook up a pressure tester and pressure up the system so that it squirts out somewhere and leaks out somewhere so that you can more easily find it. Next thing we will also want to check is the strength, the antifreeze strength. I already talked about this. At some point the antifreeze will freeze, and we want to know at what temperature it will. And so we want it in Saskatchewan here, we want it down by -40 or something like that, because we know it gets that cold in the winter. Radiator pressure cap, it opens and closes at certain pressures to allow the boiling point to raise, and so we have a test to that, so we'll check that too. And the last one is testing a thermostat. Typically we don't test a thermostat in the real world. We just, if we have it out, we replace it because it's not that expensive, and we have it out already. But what we'll do is we'll test it to see, so that you can see how it opens and closes.